Hello and welcome to the first video on my Calculus 3 or Multivariable Calculus problem solving series. In this video, we're going to find an equation for a line passing between 2 points in 3D. To do this, we're going to use parametric equations. Okay, so this question asks us to find the equation for the line that passes between 2 points, P and Q. So, the first thing that we need to do is to find the vector between P and Q. This is useful because it helps us know the direction in which our line is going in. So to find the vector between P and Q, we're going to use vector addition. So we're going to say that OP plus PQ is equal to OQ. What this is saying is that if you're starting at O and you walk to P and then you walk to Q, it's the same thing as starting at O and walking to Q. So using this, we can find that PQ is equal to OQ minus OP. So now we have OP. The next step that we need to take is to find U. U is the unitary vector, meaning that it has a magnitude of 1. U points in the direction of PQ, so they have the same angle, but the magnitude is 1. To find U, we need to take PQ and divide it by its magnitude. Now, the magnitude of a vector is going to be the square root of all of its components squared. So these two things are the same. So magnitude of PQ, these two things are the same. So the magnitude of PQ and is the square root of all of its components squared because of the distance formula. So with U, we can make the equation for the line. The equation for the line, I'm going to call R. It needs a starting point, and then it needs a vector times t. So the starting point has to be any point on the line. I'm going to pick P, but you can also pick Q if you want. So the starting point, OP, plus the vector U times t. What this means is that you're going to start on P. So when t is 0, you're going to be on P. But as t increases, you're going to keep adding more and more U, multiples of U. And this way, you're going to be moving along the line. So this will give you all the points on the line. And it's important to note here that t is going to range from negative infinity to infinity. So that's the domain of t. And when t is negative and decreases, then you're going to be moving in the opposite direction of the line. So this will give you a line that goes in infinite units in both directions. So I'm going to do an example now. So I'm going to say P is equal to 0, 0, 0. And Q is equal to 2, 4, 4. So we want to find the line that goes in between these 2 points. If you want, you can pause the video here and try to solve it yourself. So the first step we need to do is to find PQ. PQ is going to be equal to Q minus P. OQ minus OP. So we're going to subtract 2i plus 4j plus 4k. This is the notation that I'll be using. So I is the component for x, j is the y component, and k is the z component minus 0i plus 0j plus 0k. So this is just going to cancel out because it's 0. And so we find that PQ is equal to 2i plus 4j plus 4k. The next step we need to do is to find the magnitude. The magnitude of PQ is going to be the square root of all of its components squared. So 2 squared plus 4 squared plus 4 squared. Or the square root of 4 plus 16 plus 16. This is going to give us the square root of 36. Or just 6. So now we find that PQ, the magnitude of PQ, is equal to 6. So to find U, we need to take PQ and divide it by the magnitude. So it's going to be 2i plus 4j plus 4k divided by 6. Or 1/3 I plus 2/3 j plus 2/3 k. So this is going to be the vector u, which we're going to use for our equation in the line. So the equation for the line r of t is going to be our starting point. I'm going to pick 0, 0, 0, so p, plus the vector times t. So since p is 0, I don't have to write anything. So it's going to be u times t. So it's going to be 1/3 I plus 2/3 j plus 2/3 k times t. So then the t distributes to each of the components, and you get that the equation for the line is equal to 1/3 t times I plus 2/3 t times j plus 2/3 t times k. So now you can either leave the equation like this, or you can write it in parametric form. So what that means is that you're going to have 3 equations for each of the components. You're going to have one for the x, one for the y, and one for the z. So the x component would just be the I, because that's what the component is. So it's going to be t over 3. T over 3. The y component is going to be the j, or 2/3 times t. And the z component is going to be 2/3 t. So now you have 3 parametric equations that all rely on t. So you can either write it this way, or you can write it in one equation like this. Alright, so I forgot to write the unit vector notation for I, j, and k, because these are vectors. So it's important that you write the notation. For a unit vector, it's the hat on top of them. And then I also wanted to go over the second part of this problem, which is going to be to test if a point falls on this line. So the point that we're going to be testing is the point 1, 2, 3. So the first step is we plug this x value into this x equation here to find t. So when we do that, we get that 1 equals t over 3, and we get that t equals 3. So now that we have t, we plug t in to these equations to test whether they fall, these y and z values fall on the line. So I'll show you what I mean. We're going to plug in t in for the y equation. So 2 over 3 times t, but t is 3. So 2 over 3 times 3 is just 2. So y is going to be 2. And that checks out. So y is 2. And then we're going to plug it in again for the z. So 2 over 3 times t, and t is 3. Z is 2. So since z is 2, this point doesn't fall on the line, because the point that we're looking at is 1, 2, 3, not 1, 2, 2. If it was 1, 2, 2, then it would fall on the line, but it didn't. So this point does not fall on the line. So yeah, that's how you test a point to see if it falls on this line. So just to recap, the steps to finding an equation for a line is to find the vector between the 2 points, then find the unit vector by dividing it by its magnitude. Then you combine a starting point with the unit vector to make the equation for the line. And then finally, you can either write it in this form, or you can write it in 3 different forms where each component relies on t. And then if you want to plug in a point, you can test it by plugging in the values into these equations. So yeah, thanks for watching, and hopefully you learned how to write the equation for the line now.